First of all, everybody understands that the certificates are so much in use that you must have heard of the certificate. And now in this class today we will teach you how to get your own certificate. But if you start a business, you get a certificate, like Amazon has a certificate. And anytime you do HTTPS, they want to see the certificate. I mean, at least you want to see their certificate, if not yours. You want to see their certificate, and if the certificate doesn't match, the browser gives you another, please get me out of here, things like that, right? And that is because the certificate doesn't match. And so what is that certificate is what we talked about. It is an X509 thing, which has all these values. And the interesting thing is that you can go to your browser and look at any of these. And I would suggest that you do that. And that's why we have the homework actually to do that. Is that you can go into your browser, either Firefox or I have both of them, and I have not tried on the others, but Firefox and Internet Explorer. Both of them store a lot of certificates. In particular, they have to store the root certificate. Why root certificate? Because anybody can say this is a root, I am a root certificate, and then there will be a problem. So only certain companies are recognized by Microsoft, or Apple or whoever is your provider, and those certificates are stored in your browser cache, and those are the only ones which are trusted. All right, and so those root certificates can sign other people's certificates. So suppose Amazon goes to VeriSign and gets a certificate, then the VeriSign's public key has to be in our browser to verify Amazon's certificate. So that's why VeriSign is one of the root certificate that is in our browser. All right. So everybody understand why root certificates have to be built by Microsoft, built in the browser by Microsoft. And anytime you try to change that, it will complain that somebody is trying to put a new root certificate or something like that. Okay, so the root certificate is signed by the root itself, by the same person, same company, saying that here is my public key and I guarantee it. Well, anybody can say that, so we don't believe everybody, we just believe maybe 100 companies in the world. Okay, so those are the root certificates. And if you go into any of the certificate, you will find all this information which we went through the list. And some belong to version 1, some belong to version 2, some belong to version 3. Right now we are on version 3. The main thing with version 3 was, or actually wrong with version 1 was, version 1 allowed X500 names. X500 names are something that we don't generally like or use. If I go to Amazon and ask them what is their name, they will say Amazon.com. But that is not X500. Okay? And if you ask me, I would say, Jain at ACM, Jain at CSE, that is my username for the mail, but that is not X500. So X500 names were not very popularly used, so that was a problem because we could not correlate the popular name with the X500 name. So let me show you an example of X500 name. Somewhere I have X500 name. Maybe it will show up later on, but anyway. So, and we went through this slide also, is that, when you have a certificate, then, you could be that, somebody certifies somebody and then they certified. And if you want to go to somebody in Russia, obviously they are not using VeriSign certificates, so then you have to, have some higher authority who certifies both the root authorities. All right. So let's see if I find that X500 name. But anyway, there are other extensions. For example, serial number of the certificate authority and the subject keys, which means that subject is the person whose certificate it is. So for example, if I have my driver's license, I am the subject. And the certification authority is the Missouri DMV, right? So that is the serial number of them. Then, and then there is a key usage, what that key can be used for. So it turns out that some keys are used more often than others. And so they don't want you to have a key that was issued for something very, very rare use, and you start using it for very common use, like email. You send out thousands of emails, it will be very easily compromised. Right? So the key has a restriction on what it is designed for. So it might say it is for email, this is for financial transaction, whatever it is, right? Private key usage period, and then obviously they want to get money every month, every year. So they give you a time limit for which the key is valid or the certificate is valid. There are policies, and now then there is an alt name. So the alt name is the new name now. So if the X509 version 3 can have alt name, and alt name could be your DNS name. So for example, alt name could be Jain at CSE.edu. Okay, and the directory attributes, and so there are other attributes, which plenty of them anyway. So let me see if I can find that CA example. I'm sorry, I cannot find it here. But X500 name. Okay, well, somewhere in the book you might find X500 name, but they use a number of fields to describe X500 name. Anyway, so let's go to revocation. So what if the certificate is revoked? Just like this, you are driving, your car driving, drunk, they revoke your license, right? Similarly, a certificate, if you were using it and somebody gets hold of that certificate and somehow compromises it, then it has to be revoked. It may not be your fault. You do lose your driver's license and somebody makes a new picture on that one, and so on and so forth. So certificate has to be revoked. So what do we do? So for that we have to keep a list. Now some of you might remember the old days of credit card. When you use the credit card, they used to have a book in which they used to look up the name. Anybody remembers those days? Or you guys are all too young? But that is how the credit card started. Is they used to have a thick book like this. Every month the book used to come, and they would look up your number 5907, whole 16 digits in that list. That was the CRL. CRL means Certificate Revocation List. That credit card is not good, because they did not have the online method of checking it right then. They would put it on a piece of paper, your credit card, the amount, ask you to sign it, and those paper slips will be processed next week or next month or next day or in the night, right? Now we have online, so you haven't seen those lists. Basically, right now what we do is, as soon as you scan the card, it goes to the company and they check it out, that this is valid or not. So somebody has to keep the list though. Right? So there is a big list somewhere of all the revoked licenses. And so what happens is, so basically, so that is called CRL. So the certificate, each certificate has a CRL address. Okay, if you want to check out whether this is still valid today, you go to that CRL. All right. And IETF has designed actually, so basically there are two ways. One is that you go to certificate authority, and certificate authority may not be up, so that's not very good. So the CRLs would really exist at many places. So now they have something called server, CRL server you can call them, but they are called Online Revocation Server, OLRS. Now we could have multiple copies of them. So you could have one in St. Louis, one in California, and they would just synchronize themselves so that everybody has full information. Or if they don't synchronize, they could ask somebody else that, okay, do you have this in your list? So there is a protocol called OCSP, Online Certificates Status Protocol. That protocol lets them talk to each other and figure out whether the certificate is still valid. So now you could have a whole chain of OCSPs. If somebody brings a credit card from Germany into United States, it's still good because we can just go to our OLRS server, and that server could go to Germany's server and find it out. All right. So the three key things here. First of all, you understand what is CRL. Everybody understands what is CRL? It's basically a list of all these, basically all the serial numbers of the certificates that are invalid now. Yeah.
So how does CA determine that somebody's private key has been compromised?
Oh, somebody will report. It's just, you call the credit card company and say, well, my credit card has been stolen, or they will find out that somebody has made a charge that was invalid. So something will happen that will somehow, there is no automatic way other than, some misbehavior. Okay, any other questions? Second thing you should know is that they are OLRS. What do OLRS do? They just keep the list at many places. So you don't have to go to CA. CA is one company, one person, right? And you can go to any of the OLRS. Now, how do the OLRS talk to each other? And that is OCSP. Okay? All right. So now, here's an example of a CRL, actually an example of a certificate which is not valid. Now this certificate, I took it from my Internet Explorer. This certificate is assigned to Microsoft Corporation, but it is not valid. Right? It was compromised by somebody somehow. So whenever Microsoft gives you a browser, they make it built-in. Actually, there are two certificates to Microsoft which are built into your list. There are many other certificates which are built in. The reason they are built in is because they are so commonly needed. I mean, they won't build in if I lose a certificate and it is, then I have to go to OLRS. But if Microsoft loses it, that's a big deal. So that is built into your computer. All right. So there is a whole list of such certificates in your browser, and you can go and look at them. Okay. Now, obviously, this list is not complete. These revoked licenses are only whatever Microsoft thought were very common things, so that you don't create traffic on the network. And the root certificates are built in, and these are some common ones are built in. So that brings us to the end of this certification business. So 5 or 6 key points. First is we have to distinguish between master keys and session keys. Why do we need session keys?
Because if we use nothing but the master key commonly, it allows people to break the master key, and then we can't exchange session keys later.
Right, master key cannot be changed easily. So you want to keep it in a safe, and you use session keys every few minutes, a new session key. Then how do you distribute secret key? By a KDC or by public keys. KDC is one way and public key is another. And reason public keys, public keys can be used just for the keys but not for the message, right? Public keys themselves are distributed. How do you distribute public keys? You need a certificate. And that's why you need PKI. What is PKI? Public key infrastructure. So this whole system of certificate authorities, revocation list, OLSR, this whole thing is called PKI. And you know what is a root certificate, right? All right, PKIX is a profile of 509. So now 509 is a standard which allows many possibilities. PKIX narrows it down. So for example, 509 will say you can use any signature algorithm. Now if everybody used any signature algorithm, they will never match. So they have to use a particular one, and that is PKIX. And then it uses 500 names, and then the DNS names are now used in the alternate name field. And you should check out your certificate or anybody's certificate and see what is in the alternate field. Okay. Certificate revocation list, CRLs are issued, and OCSP and so on and so forth we talked about. Any question about any of the things? Everything that is in the bold you should know very well, right? All right, so the first homework. First homework is study the root certificate in your Internet Explorer. Find the certificate for this company. What is the X500 name of the company? 500 name of the CA. Okay. The reason you will find the 500 name of the company and the CA are the same. In this case, this is a root certificate, and therefore CA is that company. The certification authority for that company is the same company. Right? So you will find the 500 name, and then what version. Then you have to find out what is this use restricted to, and then you have to find out what signature algorithm is used and what is the public key. Now public key is very big, 2000 bits long. Obviously I don't want to write 2000 bits, so just tell me the last 4 bytes of the public key. Then next homework is even more interesting, is to get your own certificate and then start using it. All right, and the summary of this homework is that Mart will send you an email today, later maybe, or now, and that is signed by his certificate. You get your own certificate, then you can reply to him, because now both certificates are there. Now you can encrypt a message, sign the message, and send it to him. Right now he doesn't have your certificate, so he cannot encrypt it, because if you encrypted it, you don't have a public key yourself, so you won't be able to do anything with it, right? So right now he can only send you a signed message. So he can send his certificate, and he can send a message, and anybody can verify that, yeah, the public key says this is correct, right? But once he gets your certificate, which will come when he respond, after that both of you have both certificate, and both of you can do signed and encrypted messages. Question? No. Does it make sense? So the way it does it now, here's the thing though, you really need Outlook for this.
So we need to set up Outlook.
You have to have your Outlook, because Gmail does not allow encryption. And the reason Gmail does not allow encryption, because they want to read your email. If you encrypt it, they cannot read it, they cannot sell you anything. And then it's not good for them. All right? So you need Outlook, and our Thunderbird, maybe that does it. I don't know how it does it, but Thunderbird will do it. And any other thing which is not free. Free emails are offered for one reason: to sell you something else. Right? Send an email to your friend saying that I am looking for a mortgage. Your friend will not reply, but mortgage company will. Okay? Yeah.
Thunderbird is okay.
Yeah, I mean, see, the thing is, I don't have Thunderbird, so I don't know how to do it. Here what I have done is I have given you very detailed procedure as to how to import your certificate into Outlook, which you could have found by reading Outlook help, which I did. For Thunderbird, you have to do the same thing. You go to the help in Thunderbird and see how to import the certificate. And once you are able to do it, please send me an email, send me a description of what you did, so that I can tell it other people. Right? I don't have Thunderbird, so I cannot make it up, but this is something that everybody can just use Internet Explorer and say help and go through all that. I did that, and I wrote down the procedure here. Procedure is a little bit tricky in some cases. For example, I did one mistake. I made a request for the free email certificate from this company using Firefox, and when I went to get the certificate, I used Internet Explorer. That doesn't work. And I didn't know that until I got into that trouble. So the thing is, you have to really go through the same system that you went through to get it. All right? And so there are detailed instructions which you can just follow for if you have Firefox or if you have Internet Explorer. Sorry, what am I doing here? And then when you get somebody's message, how do you get their certificate into Outlook? So I have Outlook instructions. Yeah, question.
So I'm not sure. I found the slides on the 473-2010. So there's a lab homework 8E, and then there's a slide for description of how to do with the Thunderbird.
Okay.
So
All right, I will add that then. So what he is saying is that in my 473 class, I have described how to do Thunderbird. So I can just import that to this 571 class. Is that what you're saying, right? Okay. So somebody did that for me. Good. So I will put that, I mean, and he is saying that if you go to 473 to 2010, which he took actually, you took that class, right? Yeah, so that's what I remember. So in that class I had described Thunderbird. All right, now let's see, Firefox, importing into Outlook. Now here you think though, if you get an email from Mart and you receive it in Gmail, then what happens to the signature and the certificates, right? They are there. The signature and the certificates are there as attachment. Okay? You have to save that file, what is attached to the Gmail, and then bring it into Outlook, because Gmail will not allow you to send an encrypted email or signed email. So you bring it to Outlook, import that certificate file, and then you can send him back. So while one way is okay for him, he can send it to you to Gmail, your Gmail address, but you cannot send him back from Gmail. Everybody understand that? Right? So you really need Outlook or Thunderbird. All right. Okay, from now on, basically, now that you know, you might just want to use encrypted email, you know, but meaning among your own, I mean, but with your own friends, and I might even try to use. Sitting, how will I try? I will need everybody's certificate. So I will need everybody's certificate. So maybe I will have to ask everybody else to send me a mail as well. No, well, yeah, either you can do that too. So the thing is, if they send it to you, it will be encrypted. To me, it will not be encrypted until they have my certificate. So all right, we will have to do it, experiment twice. Yeah, go ahead.
It's kind of a slight tangent, but a number of years ago, the FBI got a lot of heat because they had something called Carnivore or Echelon or something like that that could actually go through people. Is that thing still active? Or?
No, I don't know what you're talking about, but you're saying that these certificates are not very good.
Well, they were approaching a lot of security firms that also specialized in encryption, and they wanted some sort of master key to also, if they chose to want to see someone's email.
Well, of course, so I don't know the news item, but here's what I think looks like what you're saying is that some particular root server was compromised. So just think about that. If Kamado is compromised, then Kamado will have the private key for Kamado. I mean, somebody will have private key for Kamado, and then they could issue. Well, actually, they can probably not break yours, but they can issue some false certificate to somebody else, can become Jain or whatever they wanted to become, and then they could send out emails from White House or Pentagon or wherever they want to send it out from. So that's possibility. I don't know if that is what you're talking about.
Well, I'm kind of talking about something the Justice Department had. It got taken to court, and they couldn't divulge what they actually implemented, but it was basically a program where Justice Department, if they wanted to target you, they could actually see everything you got.
Yes, got. Okay, so here you think though, right now my belief is that the certificates are 2000 bits long. Okay, I mean, you should check your certificate. I haven't checked. I'm just this certificate that was on the screen was 2000 bit long. So if your certificate 2000 bit long, it's probably possible for the government, FBI, to have a supercomputer and a cloud of supercomputers to break this thing, but it's kind of strong right now. But it is quite possible that some people are not using, some people are using MD5 or something, or 160-bit or 128-bit, so that part can be broken easily. So the whole security thing is how much compute power you have. And so you cannot always be sure. So the only strong story I have heard, I think I said to this class before about this disk storage encryption. Remember? I told you the story that they caught a drug or a dealer or somebody in South America whose disks they could not decrypt. The FBI could not decrypt because they had used one of these strong encryptions. All right? So that's an unbelievable story. That, I mean, such a strong encryption exists that once you encrypt it, nobody can read it. So, so it's pretty strong though. I mean, like this particular thing. Certificates are, if they correctly implement it, and if it is encrypted, then it should be difficult to break. Yeah. Oh, here you are. Hold on. One more thing. There is one more thing. Although FBI could easily subpoena Commodore and say, give me Raj Jain's private key. Or they could get it without my knowledge too, I think, by some court order. And then they could decrypt everything that I'm sending without effort. Does that make sense?
Yeah, I think not every security firm was complicit, but basically they were wanting a spare key, a spare master key to go through the front door. Basically.
Yeah, something like that. So the thing is, yeah, go ahead, yeah. So that, yeah, go ahead. Next.
So I had a question about Gmail. So it doesn't allow encrypting. Does it allow the decrypting? Like, does it support? Like, if we.
I don't know. Actually, I don't know. I would be surprised if it did, but please figure it out.
It's not. It's just the web client doesn't have any kind of encryption. I can encrypt from my mail client using.
Oh yeah. So I send good. So you can use your Gmail address if you use Outlook. That's what I use. I use Outlook, but all the emails you get probably are from Gmail, but I don't use the web client. That's the point. The address is valid and the mail will go to your Gmail from and to and everything else, Gmail address. Okay.